Okay, so I'm going to take you through the progress check 1. I'll talk about the common mistakes that I saw when I marked your work, and I'll also explain to you where the marks are awarded. So the first thing to point out before we start answering the questions is to be aware that you were given this formula list. It's not huge on the intermediate tier. There are in fact only two formulas they give you. One for the area of a trapezium, which you were going to need to answer one of these questions, and lots of you didn't realise it was there, and the other one for volume of a prism, which doesn't come into this paper. Okay, so the first question, negative numbers. Complete each row of the following table. The first row has been completed for you. So the place was Cwmbran, the temperature at 10 AM was 2 degrees, it went down by 4 degrees, so the temperature at 6 PM is -2. So it's moving up and down your number line. So then we're in Llanelli. At 10 AM it was -3, and it goes down by 1 degree. So it's 1 degree colder than it is there, which means it's going to be -4 at that point. In Llanidloes it was -4, and at 6 it's -1. So it's got warmer, it's gone up by 3 places, or up by 3 degrees. Now, if you aren't sure, draw yourself a little number line. If you're not sure what's going on, don't be shy. 0, -1, -2, -3, -4, -5. So we're starting at -4. We're finishing at -1. So we're going 1, 2, 3, up 3 degrees, or warmer by 3 degrees. And then for this one, we finish at 3 degrees. So 0, 1, 2, 3. Sorry, you can't see that, can you? So we finish at 3 degrees after a rise of 4, which means prior to that it would have been 4 degrees cooler. 1, 2, 3, 4. So you would have ended up at -1. Okay, so they were only interested in the number part, the plus, the minus, the up. You don't need the degrees C's. If you put them in, that was fine. And the way that that is being marked is the examiner is awarding B marks. So he's looking for that -4. If it's there, you get it. If it's not, you don't. And that's the same for the 3 values. Question 2, fraction decimal percentage equivalence. Write 7%, 3/5 and 0.3 in ascending order. So ascending order means going from the smallest value to the highest value. They're helping you there anyway, because in the answer they're actually writing that in for you. Now the trick to this is that you have to put each of these in the same equivalence. So either they all need to be written in percentages, or they all need to be written in decimals, or they need to be written in fractions. And you have to do that to get the 3 marks. If you just correctly put them in the right order, but with no workings, you're only going to get a mark for this. So let's turn 7% into a decimal. 7% as a decimal is the same as writing 7 pence if you were writing in pounds. So 7 pence written in pounds would be like that. So 7% would be 7 pence written in pounds, which is 0.07. 3/5, to turn that into a decimal, you would have to do 5 into 3. Now, the easiest way of doing this, it's a non-calculator paper, is using your junior school, what they call the bus stop method. So 5, how many times does 5 go into 3? It doesn't. So we put a decimal and add a 0, and then it's how many times does 5 go into 30, which is 6 with no remainder, so we stop. So that as a decimal would be 0.6 or 0.60. And then a 0.3 is already as a decimal, but we write into two decimal places, so we have them all the same. So we can see now that the smallest value there is the 0.07, which is 7%. So you should write it in the same format they gave them to you. So 7% is the smallest, then the 0.3, and finally the largest is 3/5. So the way those marks are ordered is there's 2 marks for getting these into the same format. So I got them there into decimal. You could have got them all into percentage, in which case that one would have been 60%, that one would have been 30%, or most unlikely all into fractions. And then there's 1 mark for the correct ordering of the numbers. So as I said, because this is making clear instruction, you must show all your working. If you just wrote those down correctly, you'd only get 1 out of the 3 marks. Okay, question 3. So we've got low-level algebra. Calculate the value of 3x plus 4y when x is -6 and y is 5. So we're going to replace the x value in there with -6. Now the 3 and the x are joined by a multiply that we don't put in because it looks like an x. But when we replace it, once it moves from algebra to arithmetic, which it does when we replace the letter, we have to put it in. So 3x means 3 times -6 plus 4 times 5. So 3 times -6, 3 6s are 18. The signs are different, that's positive, that's negative. The signs are different, the answer is negative. And then 4 times 5 is 20. So what we're working out is -18 or -18 plus 20, which comes to 2. Simplify the expression. So we got 9g, take 4f, take 3g, take 5f. So what we do is we isolate the letters that are the same. So I've got a 9g there, take away 3g. The 9 is positive because there's no symbol in front of it, so that's the same as 9 take away 3, which will be 6g. And then we've got -4f, and we're moving down the number line another 5 places. It's not multiplying, we haven't got any brackets, so it's just -4 dropping down another 5 places, so you end up at 6g minus 9f. Then we have a 2-step equation. We want to end up with the m's on their own. So the first thing we have to do is get rid of that take 7 by doing the opposite of taking 7, which is adding 7. If we add 7 to that side, to maintain the balance, we have to add it to the other side as well. So on the left hand side of the equal sign, we've got 3m, the 7's have gone, and on the right hand side of the equal sign, we've got 8, add 7 is 15. The 3 and the m are joined by a times, just as the letters and numbers were in that part. So to get rid of that times 3, I have to do the opposite of times by 3, which is dividing by 3. If I do that to one side, I've got to do it to the other side as well. So we get 1m, or m, is 15 divided by 3, which is 5. And then finally expand, so that's the command to get rid of the bracket. So you have to multiply now each term inside the bracket by the term outside. So we have to do 4 times 3x to get 12x, and then 4 times 5 to get 20. The 4 is positive because there's no sign in front of it. The 5 is negative. The signs are different. The answer is negative. So marks for that. For the first one, there's 1 mark for substituting in to the formula and working out correctly one of those values, and there's 2 marks if you get the correct answer of 2. For the second one, there's 1 mark for site of 6g, and there's 1 mark for the site of minus 9f. For C, there's 1 mark if you get 3m is 15, so correctly getting rid of the minus 7, and then 1 mark for m is 5, and then for the last one there's 1 mark for correctly expanding the bracket. Question 4. The mean of two numbers is 7. The range of these two numbers is 8. What are the two numbers? So you need to remember that to work out the mean, it's the total of the numbers divided by the count, how many there are. So it's the sum of the numbers added together divided by however many there are. So here I know that the mean is 7, and I know there are two numbers. So the total divided by 2 is 7. So the total of these two numbers is 14. So they've got to add up to 14, and the range is the largest value take away the smallest value. So they've got to add up to 14, and the biggest take away the smallest has got to equal 8. So for example, they could be 13 and 1, but if they were 13 and 1, their range wouldn't be 8. Okay, so it's not 13 and 1. It could be 12 and 2, but when you take 12 and 2 away, you don't get 8. It could be 11 and 3, and if you take 11 and 3 away from each other, so if I go through that, so it could be 13 and 1. No, because the range is 12. It could be 12 and 2, but the range is 10. Could be 11 and 8. No, it couldn't. It could be 11 and 3, because they add up to 14, and their range is 8, because 11 take away 3 is 8. So the two numbers are 11 and 3. So you need to know how to find the mean, and then using the fact you're given the mean, remember how to find out what they must add up to, and then you're looking for numbers that add to 14 and take away to give 8. So the marks for that, there's 2 marks. Okay, you get 1 mark if you correctly picked a pair of numbers that add up to give 14, and then if they also subtract to give 8, you get the 2nd mark. Question 5, angle properties and bearings. So calculate the size of angle X. So we can see there that angle X is inside a triangle. Angles in the triangle, you need to know, add up to 180. Okay, angle fact you need to know. You need to know that that box tells you that that is 90 degrees. So I know those two angles are 90 and 50, it's 140. And they're going to add up to 180, so X will be 180 less the two side angles we know, so X will be 40 degrees. Hence, give the bearing of point B from point A. So the angle factor you need to know now is that a bearing is measured clockwise from north. So north is 90 degrees, and you're measuring the turn from facing north around until you hit the line of sight to B. So that's going to be that angle, which will be 90 plus 40, which will be 130 degrees. So two facts you needed to recall there, one about angles in the triangle and the other about how bearings are measured. And the way the marks were given for that was you had a method mark for working correctly with angles inside the triangle, and an answer mark for 40, and then a final mark for your bearing. Now if you had incorrectly worked that out and then used that with the 90 to get the bearing, then you'll have had a different answer there, but you'd have still been able to get that B mark. Question 7, so this is from number properties. Find the whole number which satisfies all of the following conditions. So the first condition is it's a whole number between 1 and 40 inclusive. So the first condition, it could be 1, 2, 3, 4, all the way up to 38, 39, 40. It's got to be in that list. And it's a whole number, so there's no decimals, and it's inclusive, which means it could be 1 and it could be 40. The number is a multiple of 4, but not a multiple of 8. So multiples of 4 are the 4 times table. So 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. The answer is one of those, but it's not a multiple of 8. So the 8 times table, 1 8's 8, 2 8's 16, 3 8's 24, 4 8's are 32, 5 8's are 40. So it's not one of those. So I can knock out that one, I can knock out that one, I can knock out that one, and that one. 3 is a factor of this number. So 3 is a factor, so 3 goes into it exactly. So it's one of these numbers, but 3 goes into it exactly. So if 3 is a factor, 3 is not a factor of 4. It is a factor of 12. It isn't a factor of 20 or 28, but it is a factor of 36. So we now have a choice of these two numbers. The number is a square number. So square number means it is a number you get by multiplying another number by itself. So square numbers, 1 times 1 is 1, 2 2's are 4, 3 3's are 9, 4 4's are 16, 5 5's are 25, 6 6's are 36. 12 isn't in that list, 36 is. So the only number that satisfies all of those clues is 36. So the way that that is marked is you would have got 2 marks if you got 4, 9 or 12. So basically you got a number which failed only one of those conditions, but you get 3 marks for getting 36. So 3 marks for that. Question 8. What is the total mass when 534 grams is added to 3.5 kilograms? So they're looking here for metric equivalences. You can't add those together as they are, because that's in grams, that's in kilograms. So they're expecting you to know that there's 1,000 grams in a kilogram. So you either need to convert that into grams, or probably more likely convert 3.5 kilograms into grams, which is 3,500 grams. Now we can add on the 534 and get 4, 3, 5 and 5 is 10, 4034 grams. So I'm looking here now, I've got 4.0 0.034 grams. Well, that's not that. It's definitely not that, or that. So it must be that, but that's in kilograms. So if we were to convert that back, we divide by 1,000 and we get the 4.034. What is the total length when 35 centimeters is added to 7.8 meters? Same again, they want a metric equivalent. They need you to know that 100 centimeters is 1 meter, so that 7.8 meters would be 780 centimeters. You'd add on the 35 centimeters. 5, 8 and 3 is 11, 815, and we're working in centimeters, and there's our answer. And then the last one is pretty difficult. How many millimeter cubes are there in 4 centimeter cubes? Well, you need to know that there are 10 millimeters in 1 centimeter. So if you have a centimeter cube, so if you think of like a stock cube or a dice, then that would be a 1 centimeter by 1 centimeter by 1 centimeter cube. But we know now that that's in fact 10 millimeters by 10 millimeters by 10 millimeters. So 1 centimeter cube would be the volume of that 1 times 1 times 1. So 1 centimeter cubed is the same as 10 millimeters times 10 millimeters times 10, which is 1,000 square millimeters. So 1 cubic centimeter is 1,000 cubic millimeters. So 4 of them will be 4. Very few students in intermediate tier get that right. So although I've done all the maths for it, there's only 1 mark for each of those. But just because they give you a multiple choice answer, it doesn't mean they want you to guess. You still have to do the work to guarantee you get those right. Question 9. Percentages. Express 60 out of 300. Well, the way we write 60 out of in maths, we don't use the words out of, we use the word put it over. So 60 over 300, and then to turn it into a percentage we'd multiply it by 100. So there's different ways of doing this. You could do the multiplication first of all, so you would do 60 times 100 would be 6,000 divided by 300. You could divide by 10 and get 600 over 30. You can divide by 10 again and get 60 over 3, which is 20%. Or you could do, well, 60 over 300 would be the same as, if you divide by 2, sorry, if you divide by 3 I meant, you would get 20. 60 divided by 3 is 20. 300 divided by 3 is 100. So that's percent, so you get your 20% that way. Doesn't matter how you do it, as long as you get 20%. So the marks for 9A, there's a method for how you work it out, either with equivalent fractions or as a multiplication and division, and then your answer for correctly getting 20%. Some people were asked a question. 40% of people answered yes. A sketch of the pie chart showing this information is shown below. Calculate the size of angle X so that the pie chart can be drawn accurately. So you need to know the angle fact. Angle in a circle come to total 360 degrees. So 40% answered yes. So 40% of 360 is going to be that angle. This is a non-calculator paper, so this is where you'd find 10% first of all. So 10% would be, divide that by 10, which would be 36 degrees. I don't want 10, I want 40, sorry, so I'd multiply that by 4 to make 40, which means I'd multiply this by 4. 4 6s, 24, 4 down carry the 2, 4 3s are 12, 13, 14. So it's 144 degrees. 2 marks for that. Method mark for trying to work out 40% of 360, and the answer mark for getting the 144 degrees. Okay, question 10. So this is the question where you've got an extra 2 marks for how you organize your work. Okay, so you need to have a structure to what you're trying to do and be able to communicate that. So the diagram below shows a rectangle ABCF, ABCF, and a trapezium CDEF. Now as soon as I see that word there, I'm thinking I've already read that word once from my paper, and it was on that formula page, the area of trapezium, and there's the formula that you need to use. So we'll come back to that. So AF is 7, so one side of the rectangle is 7, ED is 8, and the perpendicular distance between FC and ED is 6 centimeters. The area of the rectangle ABCF is 91 square centimeters. Calculate the area of the trapezium CDEF. So to work out the area of that trapezium, if we go back to the front page, I need to know half A plus B times H. So A and B, I need to know the lengths of the 2 parallel sides and the distance between them. Now at the moment, I know that side, but I don't know that side. So to find area of CDEF, I need FC. Okay, so that's a line of maths, and a line explaining what I'm trying to do. Now the area of the rectangle is 91, and the way I work out the area of a rectangle is length times width. So that times FC must give me 91. So 7 lots of FC equals 91. So to find FC, I've got to do 91 divided by 7. So non-calculator paper, so I'm going to have to do a bit of work here. That's a 7 outside and 91 inside. 7 goes into 9 once, remainder 2. 7 into 21 goes 3 times, no remainder. So FC equals 13, and because I have to be accurate with my communication, I know that that is 13 centimeters. So now I know that that is 13. So the area of CDEF equals a half A plus B times H. A and B are the 2 parallel sides, and the distance between them is 6. So half of 6 is 3, and 8 add 13 is 21. So I've got to do 3 lots of 21, which is 63, and the units of area are centimeters squared. So the marks for that, there's a mark for the maths for showing how you're going to work out the length of FC by doing 91 divided by 7, and an answer mark for 13 centimeters. Then there's a method for correctly using the formula for trapezium, which you're given, and an answer mark for the area of that, which is 63. And then the OCW part, the extra bits, so you get +1 for being organised. So you get 1 mark for showing what you're doing. So it's not writing an essay. First part of that is clearly finding an area of a rectangle, and then the second you're using the area of a trapezium, and then the second OCW mark is for being consistent with your units. So centimeters when I'm talking about length, centimeters squared when I'm talking about area. So 6 marks for that question. Question 11. 200 young people are taking part in a conference held at Aberystwyth. One of the young people is chosen at random to be the chairperson. Complete the table below to find the probability that the person chosen lives outside the United Kingdom. So you need to know that the sum of probabilities must equal 1. Okay, so that's the fact you need to recall. In total there so far, I've got 0.2 and 0.3 is 0.5, 0.75, 0.85, 0.9. So they all come to 0.9. If you get in a muddle, lay it out as a column, or think of it in money. That's 20 pence, 30 pence, 25, 15, which comes to 90 pence, but in decimal. So the missing one here is 1 minus 0.9 equals 0.1. How many of the 200 young people live in Mid Wales? So in Mid Wales, the chances of you getting a Mid Walian is 0.3 times 200. Different ways of doing this. 3 2s is 6, and then it's going to be 60, because it's not going to be 600 because it's 0.3 of it, and it's not going to be 6 either. Or you could do 0.3 times 60. If you move the decimal point once in that direction, you have to move it once back that way, so it's the same as 3 times 20. Or you could remember that 0.3 is the same as 3/10. So you're doing 3/10 times 200, which is 600 divided by 10, which is 60. Again, it doesn't matter the method you use, so long as you get it right. So there's a method mark in part A for recognizing that they've got to add up to 1, and some attempt to add up what you've got and subtract, and 1 for correctly getting 0.1. There's a method mark here for writing down 0.3 times 200, and an answer mark for somehow getting 60 out of the right answer. Part 12, transformations. Describe fully the single transformation that transforms triangle A onto triangle B. So we can see there that the two triangles are touching. So we've got a mirror line between there. Okay, so what we've got is a reflection line which is going there. Now, the mathematical word that you have to use to get 1 mark is that it is a reflection. And then to get the second mark, you need to describe where the mirror is placed. Now this mirror is placed here, and here is going through the x coordinate -2. Every point on that line has got the same x coordinate, so it's a reflection on the line x equals -2. Now the most common mistake to use here is to say y equals -2, because that orange line, the mirror line, is parallel to the y-axis. But it's going through the x coordinate -2, so it's a reflection. So there's 1 mark for the word reflection, and then the second mark is to describe where the mirror line is placed, and it's placed on x equals -2. Translate, so this is another transformation now. Translate means we're going to move that shape 5 spaces in the x direction in a plus x, so the first number in that vector is your x direction, and the second number is the y move. So we're going to take each point, we'll take that point there, and we're going to move it 5 squares in the x direction. 1, 2, 3, 4, 5, which takes us to there. Then we're going to move it -6, so we're going down in the negative direction 6 squares. 1, 2, 3, 4, 5, 6. So that point there will end up there. The same journey is going to happen to every other point on that triangle. So we end up with it looking in exactly the same shape, but in this new position. So this corner here, we'll move it 5, 1, 2, 3, 4, 5, and down 6. And this one will move again across 5, 1, 2, 3, 4, 5, and down 6, which will take it to there. So that's the translation on the marks for that. There's 1 mark so long as you've correctly moved it 5 squares to the right, and 1 mark if you've correctly moved it 6 squares down. And then write down the column vector that will reverse this translation. So this means that I'm going to take this shape and put it back where it came from. So we're going to have to move it back to the left 5, so it'll be -5 and +6. And the way that we write a column vector is like that. So the x move, we're going back 5 and then up 6. Don't write it as a fraction, which is a really common mistake. So 1 mark for that. Question 13, angle properties of a polygon. So what you need to remember here from angle facts, so the exterior angle of a regular polygon is 36 degrees. So with a polygon, you're going to have so many sides. The exterior angle is the angle that you measure when you turn. So if I start there, I'm going to walk along that path and I'm facing in that direction, and then I'm going to turn and then walk, and then I'm going to turn and then walk, and so on. And in order to get back to the start, I am going to turn in a total of 360 degrees. And if the polygon is regular, it means every one of those turns, every one of those angles is the same amount of turn, the same number of degrees. So to get the number of sides, we're going to do 360 divided by each size of that angle, which is 36. So it's a 10-sided shape. Calculate the sum of all the interior angles of this regular polygon. So the interior angle is this one, which is going to be 180 less 36. So interior angle will be 180 less 36, using whatever non-calculated method suits you. Okay, I can't take 6 from 0, so I've got to write it as 170/10 rather than 180. So each interior angle is 144, and we know, because this is a 10-sided shape, that I've got 10 of them. So the sum means add them all together. So total will be 10 lots of 144, which is 1440. So marks for that: method mark for recognizing you need to divide 360 by the angle, and an answer mark for getting 10. And then more tricky for the intermediate tier is first of all finding out the interior angle and then multiplying that by 10. Question 14, nth term rules. This was not well answered in the progress check. Write down the first 3 terms of the sequence whose nth term is given by n squared take 6. So the first term, we replace the n by 1. So that will be 1 squared, take away 6. 1 times 1 is 1, take away 6 is -5. For the second term, we replace the n with 2. 2 squared is 4, take away 6, -2. And the third term will be 3 squared take away 6, which will be 9 take away 6, which is 3. So the marks for that, 2 marks for them all correct, 1 mark if you get 2 of them right. Write down an expression for the nth term of the following sequence. So when you learn about nth terms, the first thing you learn to do is look at the difference in each between each number in the pattern. So 5 take away 11 is 6, 6, 6, 6. This isn't asking for the next term, so there's no marks at all if you wrote 29 there. Because that number is fixed, that tells you it's a 6n rule. It's basically the 6 times table, but the numbers have been shifted, and in this case they've been shifted down 1. Rather than 6, 12, 18 and so on, they're 1 less than that. Not -5, -1. Okay, so the general method we use for finding the nth term rule is look for the differences. It's 6, so it's a 6n rule, and then look at what you've got to do to turn the 6 into that first number in the pattern. So we take 1 off it. So the marks for that: 1 mark if we see it's a 6n rule, and the extra mark if you get the shift correct. Question 15, tricky one, question 15. Circle the correct answer for each of the following. So 81, is 81 3 cubed? Well, no, because 3 cubed, 3 times 3 is 9, 9 times 3 is 27. The easiest way to do this is to break that down into its prime factors. So if we've got lots of space down here, 81, I know that 2 doesn't go into it, but 3 does. So 3 into 8 goes twice, remainder 2 goes in 27 times. So remember, when we're doing products of prime factors, we divide in by prime numbers. So 3 goes into that 27 times. 27 isn't a prime number because 3 goes into it. 3 goes into it 9 times. 9 isn't a prime number because 3 goes into it. 3 goes into it 3 times. These are all primes. 3 times 3 times 3 times 3 is 3 to the power of 4, which is that one. Then for part B, what's useful here is to first of all think, right, well, to the power of 5 means it's being multiplied by itself 5 times. So let's ignore the decimal point part first of all, and let's do 2 to the power of 5. So that's 2 times 2 times 2 times 2 times 2. 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32. So it's going to be a number bigger than 32. So it's definitely not that one. It's definitely not that one. The next thing to know is that if we've got a 1 digit after the decimal point and we're going to multiply that 5 times, we'll end up with a number with 5 digits after the decimal point. So it's not that one because it's only got 1. This one has got 1, 2, 3, 4, 5. That one it can't be because that's only got 1. So the only answer it could be is that one, because it's bigger. Your answer is going to be bigger than 32, and it's going to have 5 digits after the decimal point. And for this one, the power of a half is a grade B indice. It means the square root. Okay, so they want to find out the square root of 12.96. So you're looking for a number that multiplies itself to give 12.96 something. Well, 3 squared is 9, 4 squared is 16. So my answer is going to have to be 3 point something. So it's not that one, it's not that one, it's not that one. Okay, it's got to be that, because if it's 4 point something, I'm going to end up with a number bigger than 16, and if it's 2 point something, I'm going to end up with a number smaller than 9. So I have to decide which one of these. Now, if I multiply that by itself, I'm going to end up with the final digit being 30, going to end in a 6. Because if you think, if we were to do our multiplication here, 3.6, 3.6. This number here will be 6 6s, 36. So the end digit is going to end in a 6. If I do 3.3, my end digit is going to end in a 9. Now, mine is going to end in a 6. So the only one of these two answers which will be correct is that one. So you could either deduce that or you could work it out. So let's finish that off. That's going to be 18, 9, 18. Then you add up your diagonals, 6. That's going to be 11, 19, 2, 11, 12, 1, 2, 9, 6, and there's 2 numbers after the decimal point that you're multiplying, so you'll end up with 2 numbers after the decimal point there. So the answer is 3.6. So that's hard work at intermediate tier. 1 mark for each correct answer. Question 17. So probability trees are things that as teachers we like to think are at intermediate tier a nice grade B question. Dylan is having a weekend break in Wrexham. The probability that he will visit Aerith Gardens is 0.7. The probability of Dylan going to the Bersham Heritage Centre is independent of him visiting Aerith Gardens. So whether he goes to one or not doesn't make any difference about his decision about the other. The probability that he visits Aerith Gardens and goes to Bersham Heritage Centre is 0.8. That's really, really important, and where people go badly wrong with this question. Complete the following tree diagram. So when you practice tree diagrams, you will remember that the combined probabilities on any branch must add up to 1. So whether he visits or doesn't visit Aerith Gardens has to add up to 1. So if that's 0.7, that has to be 0.3. So that's where most of you got 1 mark for this question, was by putting the 0.3 there. The big mistake that people make is that they read Heritage Centre 0.28 and put a 0.28 there. That's not the case. The 0.28 is the outcome of visiting Aerith Gardens and going to Bersham. And the rule that you need to remember when moving in that direction along a probability tree is you multiply the probabilities. So 0.7 times whatever's going to go there must equal 0.28. So 4 7s are 28, so hopefully you will quickly see that that is 0.4. Once you know that that is 0.4, these two branches have to add up to 1, so that must be 0.6. And then that probability is repeated in this bottom part of the branching. So none of you that did that in the test recognized that little bit there. You've got to be careful. Sometimes they don't bother with that, and it is a straight write down of the information they give you, but sometimes they give you the outcome. Calculate the probability that Dylan visits Aerith Gardens. So he visits Aerith, so he's travelling up here, but does not go to Bersham Heritage Centre. So his path is 0.7 and 0.6. But in probability, you need to remember that and is multiply, not add. So you have to do 0.7 times 0.6. 7 6s are 42. There's 2 digits after the decimal point, so there'll be 2 digits after the decimal point in the answer. So that's it. There's 6 marks there that should be easily accessible for us at intermediate tier. So there's 1 mark for seeing the 0.3. There's a method mark. Let me just find it. There's a method mark for 0.7 times something is 0.28. There's an answer mark for the 0.4. So if I see that 0.4, you get that. And then there's an answer mark for correctly filling in the other parts of the branches. And then in part B, there's a method mark for multiplying the branches, the probabilities, and an answer mark for 0.42. Question 19. Factorize, so we've got an x squared, x and a number. So you need to be able to recognize that that is a quadratic, and that immediately that means we're going to put down the double brackets with the x's in. Then to decide what numbers, and equals 0 because we've got this equation, we need to work out what numbers go there by looking for the factor pairs of 21. So the factor pairs of 21 are 1 and 21, 2 doesn't go into it, 3 goes into it 7 times, and then 4 doesn't go into it, 5 doesn't go into it, 6 doesn't go into it, 7 goes into it 3 times, so they're repeating, so we can stop there. So we're looking for which factor pair we can add to make plus 4. Clearly 7 and 3 jump out, and to make plus 4 I want the 3 to be negative and the 7 to be positive. So the factorizing part is that in brackets, and then to solve that equals 0, either the x value has to make this bracket go to 0, which would be x is 3, because 3 take away 3 is 0, or that one has to go to 0, which would mean it would have to be negative 7. So there's 2 marks for the factorizing bit, x minus 3 bracket x plus 7, and 1 mark for writing down the solutions, x is 3 and x is negative 7. Part B, fractional equation. So we were practicing these a couple of weeks ago. Okay, we're well into the grade B work now. And the first thing we do is work out what the lowest common multiple is of 5 and 2. So the smallest number that's in the 5 times table and the 2 times table, which is 10. We have to multiply each part of that by 10. So we're going to do 10 times 2x minus 3 over 5 plus 10 4x plus 5 over 2 equals 10 over 2. And I'm putting the top values, top parts into brackets just to show that everything in that is multiplied by 10. I've kind of shifted the fraction bit over so that we can see there we've got 10 over 5, which is 2. And here I got 10 over 2, which is 5. And here I got 10 over 2, which is 5. So we do that to get rid of the fraction. Now we multiply out the brackets. So 2 times 2x is 4x. 2 times 3 is 6. Positive, negative, signs are different, answer's negative. 5 times 4x is 20x. Positive, positive, signs are the same, answer's positive. 5 times 5 is 25. 5 11s, 55. Got some tidying up to do. 4x and 20x is 24x plus 19, 25 take away 6, equals 55. I want to get the x's on their own, so I want to get rid of that 19. If I take 19 off that side, I have to take 19 off this side as well, which leaves me 24x on the left hand side and 36 on the right hand side. Now I divide by 24 to make 1x. If I divide that side by 24, I have to divide this side by 24. So I get x or 1x, and on this side, in algebra, we write 24 like that. So 36 over 24, we can cancel that down, but it's not asking us to, so it's safer to leave it as it is. So there's 4 marks for that. 1 mark would be for getting rid of the fractions by multiplying throughout by 10, and then there's an accuracy mark for getting to that line there. Then the next accuracy mark is for getting 24x equals 36, so dealing with that 19, and then the final mark is for getting a value for 1x. That's 36 over 24. Then the final question on the paper is one of these questions where you need to be asking yourself, does this look too easy for the last question on a paper, on an intermediate tier paper? The cuboid has dimensions of 40 millimeters, 25 millimeters and 12 millimeters, and the trigger for this question is the second line. All of these measurements are correct to the nearest millimeter. So they've been rounded, and when they've been rounded, it means that that height there could be less than 12. It could be, or it could be more than 12. It could be as small as 11.5 millimeters, because 11.5 to the nearest millimeter would round up. And similarly, it could be anything as large as 12. Now, when you learn this, we have the debate in class that it's most accurate at 12.49 recurring, but we use the upper limit as 12.5, even though that would round up. So the measurement rounded to 12 millimeters could be anything between 11.5 and 12.5. Similarly, with this one, it could be as small as 24.5 and as big as 25.5. And my 40 millimeters could be anything between 39.5 and 40.5. 4 of these cuboids are stacked together as shown below. Write down the greatest possible value of length A. So we've established now that A could in fact be anything between 39.5 and 40.5. So its greatest possible value is 40.5 millimeters. Calculate the greatest possible value of length B. So length B is going to be 2 of these 25 mils put together, and for them to be as large as possible, we need to use their largest possible values. So it'll be 25.5 and another 25.5. 5 is 10 and 1 is 11. So it's actually 51 millimeters. And for the least possible value of length C, so that's the heights, for that to be as small as possible, then I need the minimum possible, for 2 of those stacked on top of each other to be as small as possible. I want that one to be 11.5 and that one to be 11.5 as well, which will make a height of 23. So you need to look out for these questions and expect, if it looks as easy as basically saying, well, that's 40, that's 2 lots of 25, and that's 2 lots of 12, well, that sort of question would not appear on a GCSE paper, let alone an intermediate tier one. We will be practicing those in class. So that's it. That's the progress check number 1.